Hi everybody, Dr. Jensen here with CCJ 3701, Research Methods in Criminology. So I'm here to start your stats overview, one of many overviews that'll get you back in the saddle with knowing your statistics again. So I realize the first few weeks of class have been a little frustrating with assignment 1, being revealed to yourself what statistics you don't know and don't remember. And then your first lab, trying to get that going on. I know that. I know it can have a lot of clunky feelings to it, and maybe feelings of intimidation, some headaches, and that's normal. We're not trying to create them. We just know it can be a rough start for a lot of people. So please reach out. Don't be shy. I'm not going to think you're stupid. I just don't have that opinion of any of my students, and I never will. So realize, out of teaching over 600 students, most people flunk that little stats assignment 1 pretest, that stats review. Most people. It's very traditional to teach statistics in a way that is very mathematical and kind of feels like algebra and not particularly useful to anybody. So I'm here to change that tradition and be a little more practical with what you know and what you can do. So we're going to jump into a stats review. It'd be really tempting to go, I hate this class. I'm never watching a single lecture from this woman again. I'm not going to be able to do this. I'm overwhelmed, and not watch a single lecture and kind of just try to navigate through the labs. I'm going to tell you, don't do that. I share lots of tips and tricks that will alleviate those headaches down the road so you know what you're doing. And it becomes painfully obvious to me whether you know what you're doing or not. So make time for the class, watch the lectures, practice an SPSS. Those are the best things you can possibly do. And then sometimes people will redo the labs, and once they know the mistakes they made, they'll try them again. And they'll redo them and they'll rewrite them. That's not a bad idea. Some people maybe create their own labs. Okay, I learned how to do this, let's try it again and make sure I really know how to do this. So it's hard to motivate yourself to do it, but it pays off big time. So you can even kind of set up more practice if you like, or if you want more practice, I'm happy to send you more practice so you get good at it. Well, let's jump in to the lecture. The nature of data and variables. So this lecture is really important. It's kind of the keystone of the whole class. If you know what kind of data you have, you know what to run, period. Certain statistics can only be run with certain kinds of data. And so if you know what that is, you're always going to know what statistic to do. And it'll make life so much easier. But before you had this class, you probably had some kind of stats class in some shape or form a long time ago, maybe taught by a mathematician or a statistician or maybe a social scientist. And they had you look at all these Greek symbols with formulas. And they said, okay, what are these symbols? What do they mean? And you're like, okay, that's a beta, and that's a theta, and that's mu, and I don't know what that is. That's a sigma. Honestly, these are sororities. They're not even stats. These are sororities. So, what's really kind of frustrating is you go through these formulas and it starts to feel like algebra, and you're hand crunching everything. So, just for funners, I want you to try to guess what this formula is for. So you see a sigma in there, you see an X and a P. X is the probability, P, the individual observation, P is the probability, and is the sample size. What would this possibly be calculating? If you said the mean, you're right. So we would say this is the mean, or this is X bar. You might remember that from a stats class. Okay, what about this formula? See some similar symbols, a sigma, again, N and X. What would this calculate? Well, believe it or not, this is also the mean. So again, you could be in stats or math classes and have multiple formulas for the same statistic. I'm never going to make you use a formula like this in this class. It's not practical, and no employer will ever require you to hand crunch a statistic because it takes too much time and there's too much room for inaccuracy. You're going to use a software program like SPSS, a spreadsheet like Excel, and make sure you don't have any errors. So that's my job, is to teach you how to do that. What about this formula? What would this be about? X1 is the first individual observation, Xn would be the last. If you said range, you're right. So this is the range from the first and the last, or the highest or lowest observations, to know how many numbers are in between, to give a sense of how much data is going on between here and there. What about this formula? What is this? Now we get a little more complicated. We see a square root symbol, a fraction, we're squaring something, we're adding and summing stuff together. What is it? This is actually standard deviation, okay? But again, we can make stats really complicated if you want to. I don't want to. I don't think it's going to do you any good, okay? So statistics are intimidating because of the formulas and the notation, but they don't have to be intimidating. We know what these formulas mean substantively. The mean is the average. The standard deviation is how much variation there is around the mean. That's it. So we're here to make things really straightforward and simple so that you can use statistics in a practical way for the kind of work you're going to be doing professionally. Okay, so let's get into the nature of the data, okay? Using the proper statistical procedure or technique is guided by one issue, the nature of the data. You have to know what you're measuring. If you don't know what you're measuring, how can you analyze it? You can't. You can never analyze what you don't know. That's something my students would quote me from. Don't analyze what you don't know. I said, yeah, because you won't know what you're getting, what it means, and if you're right. So you really have to become familiar with your data and the kind of things your data can do. The nature of variables is the primary determinant of which statistical procedure to use. So what's the nature of a variable? The level of measurement and how it's distributed. So we're going to go into details as to what that is. So level of measurement is just how we classify measurement scales according to the amount of information in there about those observations. Variables will differ in how well they can be measured and how much measurable information their scale can provide. So you probably saw these in the assignment 1, nominal, ordinal, interval, and ratio. Where it falls, where a variable or an observation falls on that level will tell us how much information we can measure. Okay, so those are the 4, again, nominal, ordinal, interval, and ratio. So let's take a time out for an example. So right here, let's say we wanted to study pot smoking. And we were going to grab a bunch of people in a survey and ask them about their pot smoking behavior. We could ask them about pot smoking in a nominal, an ordinal, or an interval or ratio manner. And that's going to give us different amounts of information. So what if we just wanted to know if you smoke pot? That's it. We could ask a nominal question, just a category, yes, no. Have you ever smoked pot? Yes or no. That's it. So we put all the yeses in this category, all the no's in this category, okay? We wouldn't be able to quantify them other than just knowing how many there are in each category. Here are the yes people, the no people, okay? And that could give us information about smoking pot, but we might want more information than just have you ever. What if we ask the question, how often have you smoked pot? And we give these response types. We say never, daily, weekly, monthly, yearly, or a few times a year, or something like that. That's an ordinal way of measuring something. So not only do I know if you smoke pot or not, you either never do or you do occasionally, I now know how often you do. And I know the people who smoke daily are smoking a lot more than people who smoke weekly or monthly. So I can rank order those into more or less, or higher or lower amounts of pot smoking. Can't quantify them again because I don't know exactly how much you are, but I can know who's doing more and who's doing less, generally speaking. So I get a little more measurable information than just a category of are you or aren't you. What if I wanted to ask the question this way? How many times have you smoked pot? And I have you write in a number or select a quantity. You could say 0 times. 1 time, 2 times, 3 times, 20 times, 100 times, or whatever. Okay? So now I have a quantity. The person that smoked 100 times has smoked exactly 99 times more than the person who has smoked 1 time. I can quantify that. I can do an average. I can do all kinds of mathematical stuff now that I have a quantity. Okay, that's an interval. So again, still finding out about people's pot smoking behavior, but now I can quantify it. You can always change these variables around. We call it recoding or reducing the data. And you can say, well, I have this variable and it says, how many times have you smoked pot? I don't really care how many times they smoked. I just want to know if they have. Could you take a variable, how many times you smoked pot, 0, 1, 2, 3, 4, 5, 6, 7, 8 times, and actually just change it into a yes, no? Have you or haven't you? The answer is yes. You could take the people that have smoked 0 times and the people who've smoked one time or more and actually organize them into just yes, no categories. So you can always change stuff that you can quantify into stuff you can categorize, if that's really all you're looking for. So there's a lot of different kinds of powers and attributes that come with how we measure data. So again, same topic, pot smoking, but you can get different amounts of information depending on how you ask the question. So, and that lends itself to different kinds of statistics. So let's move into the nature of the data. So we have nominal, ordinal, interval, and ratio. You're going to hear me say these over and over and over again. As soon as I ask you what statistic you're going to run, I'm going to say, how is it measured? Is it nominal, ordinal, interval, or ratio? If you know that, you're going to know if you can even run the statistic. Why are you calculating an average on a variable that's nominal when you can't? Okay, nominal variables are just categories. You can't do an average category. We'll talk about that in a moment. So again, if you move from left to right, you see this arrow on the slide, nominal, ordinal, interval, and ratio. The further to the right you go, the more measurable information you get. So we tend to really like interval variables because they give us the most amount of information we could get out of a question to somebody on their behavior. Nominals are good too because especially in criminology and sociology, we like categories like arrested, yes, no, race, class, gender. We like looking at things that we can put people into groups and see if there's a likelihood of a certain group having something happen over another. So we like categorical stuff too. We use all these levels of measurement in social science research. So let's actually get into the nature of the data. So I'll see you for part 2, where we get into nominal, ordinal, interval, and ratio data in a little more detail. I'll see you then.